Hello, you're welcome back to my YouTube channel. So in today's video, I'm going to show you how you can extract text, tables, and images from a PDF file. So we have a sample PDF that we're going to use to demonstrate today. And also we're going to be using the Unstructured library to carry out these different implementation. So the most important part of it is we're going to be building a simple multimodal RAG application using the Unstructured library and the GPT model. So there are two external libraries that you need to download on your machine, so which is the Poplar and the Tesseract. And I'm going to show you how you can download both libraries to your Windows machine. So for Poplar, just go down and look for the latest release. So click on the release. So here you're going to download this zip file. So just click on the zip file. So which is going to be downloaded. So you can go to your download folder. So what we're going to do is we're going to extract this release library for Poplar to our program file. So what I mean is you're going to extract that Poplar library inside this program file on your C drive. So I'm going to go back to the downloads. Then you right click and click on extract. So I'm going to look at my C drive, then program file. So yeah, this is the folder for the Poplar. So the next one we're going to download is the Tesseract. So we come to the Tesseract page, then we look for download. So here you can see the exe file for Windows. So just click on it. So which is going to be downloaded. So while you are done, just click on install. So after you install it, so this is an exe file, which is unlike the Popular that we downloaded, which was a zip file. So whenever you install the exe file, it will be directly inside this program file. So you are going to see this Tesseract OCR folder here, which actually shows like it has been installed on your machine. So now after you're done with that, the next thing is we need to ensure like our machine is able to recognize the path of all these different installations. So you need to put the path to these different installations to your environment variable. So the first one we're going to do is for Poplar. So we're going to click on the library, then the bin. So we're going to copy these paths and we're going to paste it inside the environment variable. So we won't have any issue running it whenever we're working with any of it. So just click on open, then you look for your user path. So you click on edit. So here, just click on new, then you paste it. So I have it here already. I'm not going to paste it. So just paste it. So whenever you're done, so you're going to do the same thing for Poplar as well. Sorry, for Tesseract. So click on the Tesseract. So just copy the path as well. Then you open your environment variable. So then you're going to paste it just like what you can see here. Okay, so that's just all you need to do for those two different external libraries that we downloaded now. So now the next thing we're going to do is we need to move to our VS Code where we can set up virtual environments. So to create a virtual environment, we're going to use conda create. So I'll activate this environment. A kernel on it. Yes, I'm going to select the new environment that I just created now. So under this environment is where all the installation is going to be. So these are the things I need to install. So we have all our installation. So I'm going to import. So we need to create an env file where we can put our API key, which is from OpenAI. So just create the env file and paste your API key inside it. Then you're going to load it with this by using the load.env. So here you already have your API key brought in. So we just need to reference it in our code. So, but if you have any issue with how you can create your API key or maybe setting up, there is a video which I already created earlier. So you can click on the link above to access it. So this is the path to the PDF file which I want to use. Then I'm going to be using the partition PDF, which is from the unstructured library. So this is the partition PDF, which I'm calling from the unstructured library. So here I'm referencing my file paths. Then here is where we actually get the table structure. So you ensure this is added to your code, because if it is not, you might not be able to extract the tables. So as well, I instructed the image block types. So I'm going to take out the table from it. So assuming you have a table which is actually in an image format, so you can also just add a table at the front. So, and again, to extract your image among the metadata which is going to be returned, you ensure you had this image block to payload. So you set it to true. While there are different chunking strategy, just like what we see. So we have different chunking strategy. We have the basic and we have the by title. So the by title is very important. Let's say we have something like a research paper and we want to group different headings and titles together. So we can use this by title to group different things together in the same category. So while we also ensure we pass in the maximum number of characters, you ensure like you chunk it in a very good way whereby it can maintain the context of each word. So you ensure you don't have a tiny chunk and you don't have something that is too large as well. So I'm going to run this code. So here we have all the composite elements and the tables that we have in this PDF file. So another thing I want to bring to attention is the fact that the unstructured library, yeah, so the unstructured library version, so the reason why I'm using this 0.16 version is because in the latest version, I think that's 0.16.11 and above, so the tables are not actually separated. So we have the tables inside the composite element. So if you happen to prefer that, you might actually use that, probably just upgrade the version. For what I have here, I have the table and the composite element separately. So what I mean by the composite elements is just like all the text are grouped together. So in the, if you look at the PDF file, so the section headers, so you can see these section headers, they are going to be grouped together. So that's just the meaning of all the composite elements. So it's just to ensure like all our data are properly arranged. So we can click on the PDF elements. So let me just take one of it, so, and check the metadata. Yeah, so there's something they call original elements. So under these original elements, you're going to see the different header, title, text under this particular composite element. So you can see all the different things that are in the same category. So then what we're going to do is we're going to separate all these different data. So we're going to separate the table, we're going to separate the images and the text. So we're just going to group them to different buckets. So to group the table, images, and text to different buckets, so this is how we're going to do it. So we use the PDF element that we extracted earlier. So we look for table, we look for images, and the composite. So the composite actually stand for all the text. So we're going to extract them to different box. So, and then if you check the tables, so you have all the tables which is standing alone. Then if you check for the images as well. So, but whenever you're extracting your images, the images are going to be base 64 encoded. So that's what I actually use here to extract it. So I'm using the metadata, then I got the base 64 of those images. So if we check for the images, so these are the encoded formats of all those images. So while the text will have all the composite elements inside. So these are all the composite elements for the text. So to see these images, they are in base 64 encoded, but for us to view any of these images, so let's say I just want to take one of those images and view what is inside. So let's say I just want to take probably the first one or something, just to see what's inside. So I could just use the IPython to display the image. So by decoding it with base 64, then open it with image, so which is what I have here, which is the sample code here. So if I use this, then I take the first one. Yeah, so this is one of the image that I have inside the PDF file. So, and if I used slicing to check for the next one, so this is also another part of the image that I have in the PDF file. Okay, so this is just an example on how we can extract our image. So also I forgot to mention earlier, you might also want to save your image to a folder. So we need to specify that inside a partition PDF above. So you have something like this. Yeah, the image part. So you ensure you had the image part. So I think you also need to add extract image is equal to true or something. So which is going to extract the image. Okay. So the next thing again is we also want to look for the tables, all the tables that we have. So I just want to display those tables and see how the tables look like. So to do that, we can actually convert this to an HTML. So the metadata has the HTML. So I could call the metadata, then type and extract the HTML out using the metadata. So what I can do is I can say maybe for table in tables. So just do metadata. Okay. So let's see what I have inside. It should be tables HTML. Yeah, so I have all the HTML inside this table. So assuming I want to display this HTML table, I could actually display it using the IPython display as well. So let me call the first one. So this is what the first table looks like in my data. So, and if I were to look for the second table, so this is what the second table looks like. So if I go to the PDF, I can actually confirm these tables inside my PDF. So the next thing that we're going to do now is we are going to create a summary of both tables, the images and the text. We've already grouped them to different buckets. So we need to create a summary of these different chunks that we've created. So it's very important for us to create a summary before we create an embedding and put them in a vector store. So to summarize the data, we're going to use the chat OpenAI, which is the GPT-4 mini. That's what we're going to use to summarize all the test tables and the images. So actually, you can use any type of model you are interested in. But to summarize the images is, I think, GPT-4 Mini, and there's the one for Vision, which is each are the ones that you can actually use for images. But if you actually want to work with the text, you can use any type of other model that you are interested in. So I just tried to use GPT-4 Mini for the three different things. So here you're going to send in your prompts. So we define our prompt, then we have the model. So, and we also have a chain. So this is the chain. So from the elements, so this runnable pass-through is just going to send our data directly. So it's going to send it to the prompt. Then we have the model and the string output parser. So here we're going to use the batch. So the reason why we're using batch is just like we can send multiple things together. So we're going to send multiple chunks together at once. So here I'm going to call the function. So the first thing I want to do is I want to do the text summary. So I'm just going to pass in my text. So I'm going to run the code. So I'm going to run the code. Okay, I think you can't see our env file. So I'm going to check and see what's going on. Okay, this needs to be, I need to define. Okay, so I'll need to reload the env file. So this .env, I need to reload it. So we can run it again and see. Yeah, I guess this should work. Okay, so let me check the test summary. Yeah, so we have all our text summary here. So if I happen to print, let me just print one of it. So yeah, okay, so what we're going to do is we just did it for the text. So we can do same for table. So remember what we did earlier, we converted the table to an HTML format. So it is this HTML format that we are going to send to our large language model, because we can't send the table as it is directly. So remember the tables HTML I created earlier? Yeah, so this is what we are going to be sending to our large language model. So we are going to call that function that we have above. So let's say table summary. Then you just send it as it is. Yeah, so you just send it to the large language model. Okay, so now let's see what we have inside our summary. Yeah, so this is what we have inside our table summary. So it has been able to summarize what we have inside the table. Now, the next thing that we're going to do is we're going to do the image summary as well. So to summarize our image, we're going to use the same GPT-4 model to summarize it. So we're going to pass in our prompts, so whereby we give it a details of how we want that to be summarized. So then we create a message format, which is what we can see here. So in this message format, we ensure like we specify the type and the image URL, which are the necessary things that we need to set to the GPT model. So before we send in the prompt, then we pass it to the model, then we use a string output parser. So now if I run this function, which I have here, so then I say image summary. Okay, so I'm going to see you know, the summary of all these images. So you could see what we have here, which are the summary of all the images. So now we have our image summary, we have the table summary, then we have the text summary. The next thing we need to do is we're going to take all this summary, then they're going to be converted to vectors, then we put it to our vector store, which is where we're going to store all those summary. So, and again, we're going to create a multi-vector retrieval. So I'm going to show us how we're going to do that. So actually the raw text that we had previously, they are also going to be stored in a document store. So I'm going to show us how we can do that. So with the function that we have below is what I actually use to create a vector store and the multi-vector retrieval. So if you look at what I have here, I have the vector store. So this is where I initiated the vector store. And again, I'm using the OpenAI embeddings for my embedding model. So you could actually use any embedding that you prefer. So possibly the Hugging Face or any other one. So here I have the vector store, which I used as Chroma. So I'm using the Chroma vector store. So then I specify the embedding model I want to use. So this is the in-memory store, so which is actually where we're going to put the raw document. Then here I have the multi-vector retrieval, which I initiated. Then here is actually where we had those documents to the retriever. So this is just an helper function to do that. So one thing again is all those different summaries that we have. So before we can put them to the vector store, we ensure like it is converted to a document. So when we say document, this is where I'm creating the document. So it has to be in a document format, so which is what I created here. So, and again, what we are trying to do is we created something like a unique identifier. So this is these doc IDs are actually unique identifier that we use, which is created for retrieval process. So when we're creating these documents, we had a metadata to it. So this metadata is where we have the unique identifier that we call the document ID. So, and we're passing the summary, so which is what we have. So before we now add all those different documents to the vector store. So, and the raw document, this is where we are storing the raw documents. So, which are not the summaries actually. So this is just how we initiated the retriever. So if I run this code, so, and I want to call the function. Yeah, so I already created the retriever. So one thing I'm going to do next is I'm going to use this retrieval. So it's just like I'm going to ask any question from the PDF. So this is where I'm creating my query. This, then I do print documents. So which is just to see what is inside the document. But if you see what we have here, they are actually composite elements. So for me to see what is here, I could actually do maybe just loop through the documents. Then no. So this would actually return the entire data. So if you see what we are asking this retriever, we said, tell me about the deep learning based approach. So it's actually able to retrieve, I think, the closest data based on the question that we asked. So again, this retrieval is just like the information that we asked. So what it does is just it takes the question, then it looks for the closest summary from what we have. So whenever the summary is returned, it actually looked at the metadata of that summary by looking for the document ID. Remember, we created a unique identifier earlier. So this unique ID actually links back to the original document, which is the raw document. So which is how we have these results returned back to us. So in creating our RAG pipeline, so what is going to happen is the results that we got from the retriever. So this is what we're actually going to use as a context to our large language model. So this result is going to be the context which the large language model is going to work with. So the next thing we're going to do is we need to separate the result of this retrieval. When I mean separating it is we have the image in a different place, then we have the text and tables together. So before sending it to our large language model. So to separate it, we'll have the metadata of all those images in probably a list, then the text and tables are going to be in a separate list. So to run this, by sending the documents of what we did earlier, yeah, so this is just telling us like we actually doesn't have any image from this particular question that we sent to our retrieval. So what we can do is I could actually ask more question. So let me look into my PDF and ask something else. So let's say I want to ask something related to, okay, what are layout detection models? So I run the query. So I'm going to run this function again. Then here, I actually have an image here. So to view this image, I'm actually going to use the PLT image base 64 that I defined above previously. So I'm just going to send the results. So I'll just pass the images, then just take one. Yeah, so you can see like we're able to have the image which is exactly from what we have in our PDF. So which actually matched to the question that we're asking. We said what are layout detection models? So if I go back to my PDF, so this is actually what I have in this 3.1, and this is the only image that I have inside this layout detection model. So now we can see the retriever is actually doing what is expected to do. So what we're going to do now is we're going to use this retrieval as a context to our large language model. So the next step is to build a multimodal RAG pipeline where we send the context from the retrieval to a large language model. So to build a pipeline, so this is what we're going to do. So we first need to create a prompt. So this function has the information about the image message, the text message, and the likes. So if you see what is going on here, you can see the where I'm taking the context from the retrieval, and here is where I pass in the user question. So then here I build the prompt template. So here I build the prompt template, and this context test is just like I'm getting the text, which are the dictionary that we created earlier using the separate documents. So we are getting the text from there. So then we pass it to this context text, which is what we're going to use in our prompt templates. So while here we created a dictionary, this is just to define how we want to send our message to our model. So we need to specify the type for text and the type for image. So you can see the one we have for image when we are building the image result below. So when we are building the image context below, you can see where we get all the images. Then we also define the image message formats. So we have the type and the URL. So the messages is actually taking both the text messages and the image messages. So we have everything in individual dictionary. So then we pass it to the human message, which is from the GPT model. Find our multimodal RAG response. So this is actually what we do. So we have the context and we have the question. So the context and the question is just telling us like whenever we run this mrag with resources, probably we do something like dot invoke. So this retrieval is going to run, and then the result from the retrieval is going to be sent to the runnable lambda, which is executing the separate document function. So the chain is just telling us the output of the retrieval is sent to the runnable lambda. So if you look at the question, it's just telling us like whatsoever we sent is just going to be passed directory. So if you see you can see this chain again. So this chain is just telling us like we are taking the results from both context and question. So we are sending this dictionary through the runnable pass through. So this dot assign is just telling us like we want to create another key inside that particular dictionary. So the response is going to be another key inside the dictionary. So we're going to have both context and question, and we're going to have response inside our results. So the runnable lambda is actually taking the both the results from here. So it's sending it to the build prompt, which is what we have inside this function. So then the result is going to be sent to the GPT model. So we can see this chain. So wherever you see the chain, is just telling you like the output of the previous is sent as the input to the next. So, and we have the string output passer. So if I want to run this and, and pass in a query, so this is a question from the PDF. So, let's say we want to send, so let's say we want to run this, then we say dot invoke. So let's pass in the query. Yeah, so you can see what we actually mentioned earlier. You can see the context and you can see the question in our response. So then we actually have the response. So this is the response. So the result of this particular question that we asked, tell me the current layout detection model in the layout parser. So from my response, we can see, so let's say I just want to see the response alone. So what I can do is, yeah, so this is what the response looks like. So in order to improve this particular RAG pipeline, so what I did is just like in processing the outputs, so I ensured to take out the response question just to make it look more neater. So I just defined this function whereby I can be able to see the results and see the sources, probably the test source, or maybe it's actually an image from the response. So if I run this code, then we use this previous question that we sent. So then we can do, so let's just do process rag outputs, then we pass in the query again. Yeah, so if you look at the results, so you can see the results from the large language model is telling you like the current layout detection is, this is actually the results from the large language model. If you look at its sources, so this source is just telling you like the one from the retriever. So this is what actually came from the retriever. So, and if you look at this image, so this image is also coming from the retriever as well. So I can also ask another question. Yeah, so we have the results from the large language model, and from the retriever, we have these results, and we can see the image representation of the question we asked. So if I were to look at the PDF and just confirm, and just confirm if this is actually, the right thing. So you can see it actually takes out the image from here. So, and if you look at the text, it's definitely same thing with what the large language model is returning. So this is the end of this tutorial. If you have any question, please drop them below. Also, I've created some introduction videos on LangChain and LangChain Runnable. If you found this tutorial helpful, also subscribe to my channel. This actually motivates me to create more videos like this. Thank you for watching, and I would love to see you next time.